aperture radar image processing and computation techniques. First, I want to explain that what's the aperture in Turkish meaning, maybe you don't know, açıklık, sensitive açıklıklı radar. And what's my content? Firstly, I will explain about what's sensitive aperture radar and what is the image characteristic, why we are using this characteristic. And then there are some image compression techniques for SAR images, and I will choose those image compression techniques, and one of them is JPEG based on DCT, discrete cosine transform, and JPEG 2000 based on wavelet transform, and how we can measure the performance of these images with mean square error, peak to signal noise ratio or signal to noise ratio. I will summary these of them, and then I find an application for that manner, and I will compare this JPEG in DCT and JPEG 2000 based on wavelet transform. We can compare together with using different parameters. And firstly, we didn't take a radar course, so I want to explain what's the radar. Radar is an acronym for the radio detection and ranging radars. Work like a flash of camera, but at radio frequency. And what is the SAR systems? SAR systems are used in satellites and aircraft systems and take an image for the Earth surface, like that. And they use the movement of the antenna and signal processing to enlarge the effective aperture of the radar. And SAR is an active imaging system. What's the active imaging system? Like that in flight in here, and some flight path, and some scattered in here, and they range the data, and SAR image algorithm results in the image of the ground. And SAR image radars in working on 1 and 10 GHz. What's the meaning of this? We can show electromagnetic spectrum in here, like in here, radars in microwaves. And what's the advantage of the SAR? Why we are using this system? Because of the SAR aperture radar is working all weather conditions, or rainy, stormy, another one is no differences, and a lot of applications in here: agriculture, ecology, geology, oceanography, hydrology, military. And what's the nature of SAR? SAR has a high volume of data and more information in high frequencies in the optical images. What's the optical images? Optical images is the natural images. I can show you some skin forms. This is from capturing normal optical sensors, and this is the imaging for the SAR. This is the more clear than the optical images because of the high frequencies, high volume of data, and this kind of characteristic we want to high volume of data and high volume of high frequencies. We want to store and transmit it because of we want to show that, so that we can also use some compression techniques. What's the SAR image characteristic? SAR image characteristics in digital form, so that they are characterized by pictures, elements, pixels. And this each pixel refers to the radar backscatter on the ground. What's the backscatter? It's in here, come to radar signal and then come back. It's like that. This is the backscatter. And amount of the backscattering gives us some gray levels of the objects. For example, in water has a little backscatter, like that, flat surface. If little backscatter, this gives a darker image. And if the foil increase, gives a medium gray level, a light tone in here, like that. And buildings gives us the light tone. You can see in here, light tones. In general, large energy was reflected. Large energy was reflected to the radar dark feature in here, light energy and darker, and if the very little energy was reflected, then it's brighter pictures we can get. And now there are image compression techniques, and two kinds of image compression techniques: source coding or channel coding. And source coding concerns the process of the encoding information using fewer bits than an uncoded representation. Channel coding is aimed to find codes which transmit quickly and protect their transmissions against errors. So that now we cannot relate with errors. So that I will show you source coding, lossless coding and lossy coding. Their advantage of the lossy coding and lossless coding. For example, lossy coding is the advantage of the overdoses ones, lossless ones, is that typically produce lower compressed bias, but we can not reconstruct our signal maybe properly. And another one, reduce the image by permanently eliminating certain info or especially redundant info. And lossy coding, JPEG, one of the technique, and JPEG 2000 another technique. There are advantages of the JPEG. A lot of advantages of the JPEG also, I think Zeynep is also related with this subject. And some of the disadvantages of the JPEG, clear artifacts at very low bit rate, and image quality is not maybe good. And difficult to apply very large images is also designed for continuous tone images. For example, computer-generated or binary image bad performed. And JPEG 2000's compression performance is superior, also allows to process large and high-precision images. But in hardware and software implementation, DCT is less expensive than the wavelet transform. JPEG 2000, I'm sorry, 200, I wrote in there. And DCT less expensive than wavelet. DCT 2000 is wavelet transform based, and JPEG is based on DCT. I will show you here is in Buenos Aires. I talk about the JPEG is in very low bit rate, is not good quality. In here you can see the velocity memory stored space, and this is the quality. And also we can show the large images. What's the quality of the JPEG 2000 in here and JPEG in here and their memory spaces. And how can we measure this performance? Image fidelity measures the goodness of the compression method, and they are mean squared error and signal to noise ratio, peak signal to noise ratio. They are provides us some informations. For example, I said that I researched some applications. They are applications from getting the data from the Earth of surface, and their compression techniques they show us. Compression in numerical analysis, mean square error, for example, we can see the aircraft and helicopters and shelters is more numerical errors for the cars and tanks because of the larger data in that aircraft and shelter. Another one is PSNR and CNR and PSNR. PSNR is increased with the increasing bit rate, like that. These are for our performance evaluation. And another one is image interpretation. How can we interpret the images? One of them is the National Imagery Interpret Rating Scale. This is the level, 10 levels, 0 to 9. 0 worst quality, 9 is the best quality, present us. And flat analysis. Flat analysis evaluate the compression techniques with numerical and subjective metrics. So numerical one is mean square error like that, and subjective is the national NERR. And I will show you, and we are compare them. How can we are based on techniques, coding rate from 0 to 16, and memory computed of number of pixels times coding rate, and NER levels. And this is the applications. For example, this is the aircraft application. In here is the all of the pictures, original pictures have 512 pixels and memory and 8-bit coding rate. We can show coding rate in wavelet, JPEG 2000, and JPEG is the DCT, discrete cosine transform. Quality factor and coding rate is the, actually, if we have a low compression ratio, high bit rate, or high quality factor. We can compare about this kind of.
You have lost one.
Okay, I will summarize that. And we can image interpretability. You can see that if the coding rate has high and JPEG emits and the wavelet transform is better than JPEG. And you can see also wavelet and JPEG quality factor is low. Also wavelet is the more accurate and more clear than results. A lot of pictures in here, just the same results, different pictures. And we can show the wavelet based on maximum symmetry, preserve object edges, and DCT based on highlight shadow regions and create blocking artifacts. And